Chapter 13, Lesson 2, Greatest Common Factor. So we're going to take what we did yesterday, finding the multiples, or I'm sorry, finding the multiples, finding if the number is divisible by putting it into play. So a couple things I need to know before I do anything else is, what exactly is a factor? You just kind of have to know what a factor is in order to find one. Well, a factor is a number you multiply by another factor to get a product. So if you see, here's my multiplication problem written in vocabulary terms. Factor times factor equals product. Now you recall we did discuss this in chapter 7 and 8 when we did multiplication. Now, there are 3 different ways we can go about doing this, but in order to do this first, we have to be able to list the factors. So again, when I list the factors of a number, where's the best place to start? Well, at the beginning, with 1. Except for 1 and 0, every number has at least 2 factors, 1 in itself. So 1 times 25. Well, is 2? No, I think I go back to my divisibility rules. Do I need to mess with the even numbers? Nope, because 25 is odd. 2 plus 5 is 7, so 3 doesn't work. 5. 5 times 5 is 25. Now, I only listed 5 once here because I didn't need to list it twice because it's the same number. So 25 has 3 different factors: 1, 5, and 25. Now 72, again, I start with 1 and 72. Now you'll notice the space that I leave in between here. That's because I know I've got a whole slew of numbers to go in between. Okay, 72 is even, so I know 2 is divisible by 72. So 2 times 36. 2 plus 7 is 9, so 3 times 24. 4 is divisible by 72, so 72 divided by 4 is 18. There's a 2 and a 3, so I know 6 divisible by 6. 6 times 12. And then finally 8 and 9. Now, 72 is a basic fact here with 8 and 9, so that's why I knew that. The rest of these, you usually have to use your divisibility rules to figure them out. So if you need a calculator to help with your division here with the 2, 3, 4, 5, and 6, hey, use it. Moving on, the one last example that we have here is 100. So I start off with 1 and 100. Okay, 100 is an even number, so 2. So if I split 100 in half, I get 50. Okay, 3, 1 plus 0 is 1, so 3 doesn't work. 4 does work. 4 and 25, I think quarters and a dollar. It ends in a 0, so 5 works. 5 times 20, and it ends in a 0, so 10 also works. So that's why I have a 10 there. Now that we know what factors are, let's find out what exactly it is, or how we can list the factors. So we're going to do 36 and we'll do 60 together, and then you're going to be off on your own. So first and foremost, remember we always start with 1 and 36. Now make sure that you give yourself plenty of room in between. 2 and 18, okay, because 36 is even. 33 plus 6 is 9, so 6 and 12, or I'm sorry, 3 and 12. 4, it is divisible by 4. 4 and 9. It does not end in a 0, so 5 doesn't work. And there is a 2 and a 3, so I know I gotta have a 6. So here are my multiples of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Alright, let's try 60. So I'm always going to start with 1 and 60. It is even, so I'm going to go 2, and 60 divided by 2 is 30. 6 plus 0 is 6, so I know it's 3. 3 and 20. Okay, think of a clock for 4. 4 and 15. 5, it ends in 0, so it's divisible by 5. 5 times 12. There is a 2 and a 3 here, so I know I've got to have a 6, so 6 and 10. 7, no. 8, no. 9, no. And I've got a 10, so that's how I know I finished. So now you get to try 48. Let's see, 48, sorry, and 30. So go ahead and pause it, try it, and let's see how you did. My multiples of 48. start with 1 and 48. 48 is even, so 2, 2 and 24. 4 plus 8 is 12, so I've got 3 and 16. The last two numbers are divisible by 4, so 4 and 12, and then 6 and 8. Here for 30, 1 and 30. 30 is even, so 2 and 15. 3 plus 0, so 3. Ends in a 0, so 5, and 5 times 6. Now, how do I know when to stop? How do I know I don't keep going on? Well, look here how when we start at 1 and 48, we keep working our way in the middle, keep going in the middle, and then all of a sudden when I, like 6, and then 7, and 8 on the other side, like the other half of the numbers, that's when I know I'm finished. So, listing the factors is one of the way to find the greatest common number between the greatest common factor. So if I'm looking at 36 and 6, what's the largest number that they have in common? Well, I'm looking, and to me it looks like 6 is a number they have in common. 12 is a number that they have in common. So of these, which is the greatest number that they have in common? That's right, 12 is the greatest common factor. Okay, so they not only they're common factors, but 12 is the greatest common factor. Okay, and all you gotta do is circle it. Looking at 48 and 30, to me it looks like 6 is the greatest common factor for 48 and 30. Now, here's another way to try it. Here's another way to find greatest common factor. It's called a division ladder. Now here, I don't have to list all the factors. All I have to do is I have to come up with, hey, what's one number that's divisible by 42 and 56? Well, they're both even, so I'm going to do 2. So this is 21, and 56 divided by 2 is 28. So all I did was 42 divided by 2, got 21. 56 divided by 2 is 28. Well, is there a number I can divide by both 7? Or divide by both 21 and 8? Yes, it is. It's 7. 3 and 4. Is there a number I can divide by both 3 and 4? And one's not a choice. Okay. No, there's not. So what I do here with the 2 and the 7 is I multiply them together, and that gives me 14, which 14 is my GCF here. So go ahead and give the video a pause and try to find the greatest common factor using division ladder for 63 and 90. Here we go. This one's a whole lot easier. Okay. 9. 63 divided by 9 is 7. 90 divided by 9 is 10. And the only number that I can divide by both 7 and 10 is 1. So I stop there. Now, what if you did this? What if you started with your divisibility rules and you did 3? Well, 3 divided by 63 is 21. 90 divided by 3 is 30. Well, I can divide by these by 3, and I get 7 and 10. Hey, isn't that what I had to begin with? Yeah. So 3 times 3 is 9, and 9 is my greatest common factor. So you see, it doesn't matter which method I use, or what number I use, I'm going to come up with the same exact answer. Okay. Last but not least, factor tree. So with the factor tree, what I have to do is what numbers, when I multiply them together, that give me 27. So 3. Moving down here is 3. 3 times 1 is the only number that I can multiply together that gives me 3. So 3 can't be split apart any further. 9 can be 3 and 3. Okay, so I'm done there. Moving down here to 20. 4 and 5. 2 and 2. So what numbers do they have in common? Okay, what that I have left over? 3, 3 and 3. 2, 2 and 5. They don't have any in common. There are no numbers in common. So they don't have if they don't have any in common, it's a 1. My GCF is a 1. Now, I said you try. You try you make your factor trees, and then we'll talk about how to find the GCF. So I've completed my factor trees. Now again, your factor tree doesn't necessarily have to be the same as mine. All that matters is I have two 2s and 2 3s down here for 36, because 2 times 2 times 3 times 3 gives me 36. And then for 45, it doesn't matter as long as you have 2 3s and a 5. Now, what I'm looking for is what numbers do they have in common? What numbers are the same? Well, if I look at what numbers they have the same, they've got a 3, a 3, a 3, a 3. So what I do now is I multiply. I multiply the numbers that they have in common. So what is 3 times 3? 9, and that is my greatest common factor. Now, well, Mr. Skura, which method do I use? Well, folks, it's up to you. I don't care which method you choose, as long as you get the right answer. Now, what you'll figure out is this. Some methods are much better, much faster than others. So what it does is takes a little trial and error with each of them. So don't get stuck in your way saying, I'm only doing this, I'm only doing that. Try them all, and then pick out your best one, pick out your favorite one, or pick out, once you use it enough, you'll understand, hey, this one works best in this situation. So that is finding the greatest common factor.